Hello, this is Paul from Forza Tech. In this lecture, we're going to learn an important application for integration, which is to find the area of a surface of revolution. Okay, we learned the value of a revolution, right? A value of a solid of the revolution, but we don't know how to find the surface. So later we have four cases, okay, and four cases, and each different. So please pay attention to each case. All we need to do is to understand why we have this formula. If we have a formula like this, and later is easy to do, just do normal calculation of a definite integral, okay? So let's look back. The first case is a rotated y equals f about x. What does that mean? If we have a function y equals f here, the domain is from A to B, and this is curve, right? Take this curve, rotate it about x, and then we get this kind of graph. Okay, and how to find this area of the surface? The idea of integration is cut in pieces, right? How to cut? And of course, because the variable is x, I guess from A to B, we can cut A, B, these x in pieces. That means we can do integration non-x, right? Let me look at it. If I cut x here, and then take each increment is delta x, so we have another cut, which means x plus delta x. And so we have the first is y, the second height is y plus delta y. Okay, and now we get this point and that point. Okay, link these 2 points together is a line segment. So can you think? Okay, the first cut, this piece is exactly, we take this line segment. Okay, the distance is ds. We learned the last topic, right? We take this 9 segment rotated about x, and we get this. What is the shape? Okay, this shape is not a cylinder. Okay, if it is a cylinder, it's very easy, right? However, it's not a cylinder. Why? Because even the top and the bottom is both circle, but the radius are different. Can you see? The first radius is y. The second radius is y plus the y is different, definitely. Okay, so however we do know what is this shape. Okay, what is this the solid or the shape? So can you see exactly that is a portion of a cone. Okay, and the top is a circle, and the radius r1 different from the bottom circle. The radius of r2. Okay, and all we need to find this one piece area. Okay, that's the surface area of a portion of a cone. You know now. The surface is this surface area of portion of a cone, not a cone. All we need to do is use the formula of this portion of a cone. So what the formula? The formula is here. The area of that is 2 pi r times L. 2 pi r is this, is half the average of r1, r2. It is. If we draw a circle, is more. This is just the average circumference of the middle circle. Okay. That's the average of the top circle and the bottom circle, and then times the length distance. Okay. Keep in mind that we need to use this. How to prove this? The next page we are going to. Let me use these results here. Okay, to find this area for this portion. Okay, area of this one part, one cut is 2d. Do you remember 2 pi r? 2 pi r is the first radius is y, the second radius is y plus delta y, which means the average y and y plus y divided by 2, right? This is the average. 2 pi r times this distance, okay, or the length of the side. The length of the side is ds. Okay, we learned the ds the last topic, so I'm going to show you what is the formula for this ds. So first 2 pi r ds, and this we do approximation. This exactly we can use 2 pi r, okay, and then we can use 2 pi y. Sorry, this is y plus delta y, because delta y is so small. We take it away, and then we have I mean the average radius is still use y to describe. Okay, and 2 pi y times ds. And the 2 pi y is the average circumference. This is not exact proof, okay, just to give you idea. how to get the formula directly. And we look at if we already find the one piece, okay, how to do, and do integration of all the pieces, right? This is one piece and the integration, so we get all the S is the surface, okay, all the surface. And we have this, and this time because we cut the X, that means we need to do integration along X, right? So what is Y we know is fx. What is ds? Remember, ds we have a square root of dx squared plus dy squared. Take x away. Why take x away? Because take x, factor x out, because we're going to integrating along x. So we have this ds. Remember this? So we have ds. Okay, we put it here. This is the first formula. So I hope now you get the first formula. Integration, because we integrate along x, so x from a to b. And the 2 pi y is the average circumference. And the times this is ds. 2 pi y ds, this is the area of this one piece. Okay, this is the area of one piece. And then the integration is all the areas of the surface. All the other cases are very similar with this. Okay, so I hope you get the idea. Okay, all the idea is here, the middle. As all the surface is 2 pi y ds do integration. Okay, 2 pi y ds is the surface for each piece. Okay, and then now we take a little bit of time going to prove. Okay, so we need to use these results. Let me see how to prove this. It's not difficult. Okay, just follow, very easy. Okay, so we have a coin here. We take the top away, okay, and then we cut the top, and then we have the area. Okay, we have a portion of a coin. How to find the area? We just have a formula, right? And we say R is the average, or 2 pi R is the average circumference of the top circumference and the bottom circumference, the average circumference, and R is the length. How to find this? Let me go into prove. First, we definitely need to use the surface area of a cone. Probably someone you forget what the formula, okay? And the formula is here. Is pi r. R is the radius. Pi r times l. L is the length or the side. Why we have this? You can cut and then expand. See what do we get? We get a section of a circle, right? We get a section of a circle. We learned this from trigonometry. How do you find the area of a section of a circle? Which means 1/2 times this L squared times theta. Theta in radian. How do you find the theta? Theta is the length. Okay, 2 pi r. Why is 2 pi r? Because that's the circumference. Okay, 2 pi r over L is theta, right? And simplify, you get the formula. See, that's really easy, and we're going to use this formula to find this section, find this area. How do? That's easy. And we have a big cone and have a small cone on the top. Okay, we use the large cone, the area of the large cone minus the area of the small cone is what the area we need, right? So use this formula. I want to look at use this formula. This is the area of the large cone minus this the area of the small cone, and then we put the R. We put the L1 together. See, we have L1 is this type. Pi L R2 minus R1 times L plus. Okay, so now we have almost everything. We don't want the L1, so we want to take L1 away. So how about this? R2 minus R1 times L1. We need to find this term. Find this term, we need to use the proportion. Okay, it's a proportion of this right triangle and this big right triangle. Proportional. Okay, so we have this proportional equation. R1, these sides over these sides, is this sides L1 over these longer sides L1 plus L2 proportional equation, and then cross multiply, we get this minus R2 L1 both sides. Okay, so we get R2 minus R1 L1, okay, equals R1 L. What does this mean? That's definitely we need. So we plug this into R2 minus R1 parenthesis times L1. Okay, is what? Is R1 L1. R1 times L. So if I put these two here, that's definitely what we get, right? Okay, we get this, and then we factor the comma, we factor the pi L, and then middle is R1 plus R2. Okay, we arrange it into this average over 2 times 2, and then we will see this is exactly the average radius, right? Okay, average radius. That's the formula. What do we get? You can think about it, this formula. Okay, this formula is meaningful. Okay, why the average of a portion of a coin is this? Okay, you can imagine if you take this out. Okay, if we take this bottom is the big, if we use it, you can think about this. If this is a cylinder, okay, the area of the top and the bottom both it is a big circle. Okay, what is the area of the surface of a cylinder, which means this circumference times the height, right? However, this is not. What is if the cylinder is a small circle? Okay, use this circumference times r is the small cylinder. However, for our this portion of a cone, and the area is between the big cylinder and the small cylinder. Okay, you think it's between, and exactly is what? Exactly is the average. Okay, is the average of these two cylinders. Okay, the average surface. Or you just simply memorize this, and we have to use this. Okay. So now let's look at it. Other three cases. Okay. This case, and everyone look at the case 2. Rotated the y is rotated the x equals y means this curve is described, and the variable is y, and we say the independent variable is y. The dependent variable this time is x. Okay, means what? Okay, we know the domain is talking about is y, right? Y the domain y is from C to D, and this is a function x of y, a function x of y. If we have these functions, and however is dr rotated about x, dr rotate about x. How to find the surface of the revolution? You can think. Idea is similar. Okay, all we need to do is cut in pieces to integration, and I cut 1, but this time how to cut? In the no longer cut x, y, because this curve is described between C to D. Okay, it's easy to do this. This time is this cut. Okay, don't worry. I cut this one piece to get what? To get a 9 segment. Like I cut at the y, and the y plus the y. So I get this point, link these 2 points together. We get the one piece of the curve. We get the one piece of the curve, and they take this one piece rotated about the x. Definitely we get this shape, right? How to find the area? This is definitely the surface area portion of a cone. We just discussed the formula. Okay, the formula we need to use the average circumference. Average circumference. The times the length. Okay, which is ds. Let me see. 2 pi. This is the average. Okay, the average radius. 2 pi times the average radius is the average circumference, right? And times the length ds. Okay, we do approximation is dr 2 pi y ds. The 2 pi y, you know, is the average circumference. ds is the length. That's the area. Okay, and then what do we need to do? If we find one piece, and then do integration. So all the s, the area is integrated 2 pi y ds. Okay, this is the general formula. Okay, is better to memorize this formula. Okay, it's not to memorize this one. Why? If you know this, it's easy to get this. First, what is ds? This time, ds we need to use this form. We learned the ds from the last time. We have 2 case, right? This time dx squared plus dy squared square root is ds. We need to factor out, we take out the dy. Why? Because we need to integrate. Why we need to do this? Because we need to integrate along y. Okay, because we need to integrating along y. because it already shows you y. We cut the y in pieces. Okay, get each piece rotated, get this is area. Okay, and then now we plug in 2 pi y. Okay, y is the integrating variable, so we leave y here, no longer fx. Okay, y put it here, and then ds is going to this formula. What is the limit? The limit is integrating along y. Y is from c to d, so we integrate from c to d. This is the second case. I think now you get it. Okay, all the cases are very similar, right? And two more cases. So this time we have a case 3. Rotated have a function. This function is y of x. Okay, x is the independent variable from a to b. See, we have a function rotated this. Okay, rotated this. Okay, along y. Rotated this function about y. Okay. And now, how to get the area of the surface? We know how to cut, everyone. So how to cut? Because the independent variable is x. So keep in mind the independent variable is x, so we need to cut x. It means later do integration we have to do along x. Okay, we cut one piece, take x to x plus x delta x. Okay, we get this 9 segment. Okay, we pick this 9 segment rotated, we get the portion of a cone, and the area is here. 2 pi times the average of the radius is dx. Okay, 2 pi x, this is the average circumference times the length ds. Remember this formula, and then do integration. Okay, this is general formula. This time is, keep in mind, is no longer y, right? Y. Okay, we go back and look at the detail, which is different from the last one. If we rotated at the y, the radius is going to x. Okay, rotated along x, and the radius is going to y. That's the big difference. Don't make this mistake. 2 pi x ds. Okay, and then what do we need to do? Ds this time is this term. Y we need to take x out. Or you can imagine take x inside is dx square plus dy square is ds, right? Why we need a dx here? Because we need to integrating along x, because we cut the x in pieces. Okay, so let's look at the formula. AB is the integration interval, and the 2 pi x is the what? The average circumference, and the times this is ds. The average circumference times ds is the area for this one piece. Okay, and the integrator is all the pieces. No bigger difference, right? One more, the last case. Can we see this? We have a still similar graph as the last one. However, this time the function is different. The curve is x equals y gy, which means the independent variable this time is y. Okay, a function of y. This is y. Where is y? Y from c to d. Okay, we have this function. X is a function of y this time, and then we get a curve, of course, and then rotate it. How do you find? Look at what the difference from the last one. And this is the one cut. Okay, after we cut this, we cut that. Different from the last one. Last one we cut x, right? Because the independent variable x. This time the independent variable is y. We cut y in pieces. We cut this one piece. Okay, and then we get this 9 segment rotated. We get a portion of a cone, and then what is the area of this piece? 2 pi x, average circumference. Steer x, keep in mind y, because this is x, this is x plus that x. To average and the approximation, steer 2 pi x. Okay, average circumference times ds. ds is here. Do integration, that formula, general formula, and the detail is 2 pi. Keep in mind that this is x, no longer put x here. Why? Because we cut y, we need to do integration along y. So ds this time goes to this. Okay, goes to this ds. we put a ds here. We need to integrating along y, so x we need to change it to y. What is x, y? X is a function of y, so we put the gy to here. 2 pi gy, do this big integration. That's the formula. So we have almost everything. Okay, if someone you understand that this formula, that's everything. Now what do we need to do? We just use the formula to integration. Okay, find the area. I have 3 examples to show you. So the first, can we see these questions? Okay, so find the area, the surface rotating. So remember, rotate by the x. Okay, which means what? Case 1 or 2, right? We have 4 cases. The case 1 or case 2. This is y is a function of x. We say y is a function of x. X is the independent variable, which means what? This is the case 1 or 2 is case 1, right? So we get it. This exactly is case 1. So we need to use the formula from case 1. I will put the formula here. What the formula? Can we see the formula? Is this s equals integration 2 pi, remember, along x, 2 pi y ds. It is a formula, right? Okay, this is the average circumference times the length. This is the area of one piece, or you say is the area of a portion of a cone. That's the formula. You're going to the first case to find this formula. How about the ds? Is integrate along what? Because we cut x, integrating along x, we have to integrating along x-axis. Therefore, you know what the formula for ds this time. Okay, I put the formula here. Integrating along x is from 0 to 1. 2 pi. Okay, I'll leave y here first. What is the formula for ds? That means what the formula for ds? If I put the formula for ds to here, is what? Is this? Is 1 plus, because we integrate along x, we take a dx out. Inside, you know now, dy dx square, and then dx. Okay. This total term is ds. Okay, we learned this from the last topic. If we have this now, almost everything, right? Integration, let me see, we know y. We need to know what is dy dx, right? We need to know dy dx. Dy dx is 2, so this is easy. So we put the integration 0 to 1. 2 pi y is 2x. 2x, and this is the integration 1 plus, we said 2, so it's 2 square, right? Okay, and then dx. And this is a power function, so very easy to get the results. We use the fundamental. And 4 pi, I take a 4 pi. Okay, of course this is square root of 5. I take a 4 square root of 5 times pi, all the coefficient out, factor out, and then 0 to 1. What do we left? We only left x. This is power. Okay, you know. Pi, this is a 1/2 x square, right? From 0 to 1. So now we do calculation. We got the 2 square root of 5 times pi. This is the answer. Okay, so we look at these examples. All we need to do is build the formula. Okay, the formula is the most important. Let me see another questions. You can see. Determine which case. Case 1, 2, 3, or 4. Okay, and along still rotated about x, which means case 1 or case 2. This time I look at what is the independent variable. It's y, right? X is a function of y. X is a function of y, which means this is case 2. Remember the second cases. Okay, now what do we need to do? We need to do formula, right? So I need to find the formula. In case 2, what the formula? Okay, if I put it here, S is this. Because this is dr rotated by the x, so the radius is dy. Average circumference is 2 pi y dr, and then dr ds. Remember, 2 pi y ds. This is the average surface of a portion of a cone. That's the formula. Okay. Of course, in the formula, what ds you need to know is integrating this time. Integrating along y, right? Integrating along y. That's the different from the last example, last question. Because it's integrating along y, we need to have dy outside. Okay, so later we're going to see. I will put here. Here's 2 pi as daily y here. We get this formula first. What that formula? The formula is square root 1 plus. Okay, keep in mind that here should be dy, right? So here is dx dy square. You can imagine you take a dy inside is dx square plus dy square is ds. Okay, you know. This is the one, so don't miss. Do we know why? You don't need to change y to x. Why? Because y is the variable of integration. Okay, so that's good. Leave y here. All we need to do is dx dy. Do we know dx dy is the derivative of x to y, which means 2y, right? So that's 2y. Okay, easy to find the derivative. And we plug into. See, we should get the answer very fast. So let me tune my little, see if we can see it clearly. Okay. And now I will put if we put it here, we need to do what? It's better to put the interval. Okay, you already go to dy, right? So what the interval? It's from 0 to 1. Integrating along y is from 0 to 1. Okay, don't miss this, otherwise we don't know how to do. Now I will put this in is 0 1 2 pi. Keep in mind that y is the variable, okay, of the integration, so just leave here, and then times square root 1 plus 2y square, right, dy. Probably you know this is too complicated, but don't worry. Okay, y and the dy put it together is what? Is dy square. So you can do substitution. So definitely we can do this substitution. Look is complicated, but it is really not. Okay, do substitution. We do substitute this. You see, we say up here, u equals 1 plus 2y square is 4y square. I do this substitution. Okay. And if we do this substitution, the interval we have to change, right? The limit we have to change. Y from 0 to 1. Y from 0 to 1. So u is from 1 to 5, right? 1 to 5. Okay. Put it here. We need to use this information. Another is dy. Y dy, definitely we can find a word. Du equals a y dy, and this means y times dy. See, y times y, if we switch order, y times dy, we have y times dy is 1/8 du. Okay, this is the one we need. We put all these three. Here's the substitution, right? That's the substitution. Okay, if we do the substitution here, how many we get? I think it is 2 pi. We can factor it out, right? I put the 2y outside, and then integral from 1 to 5. Okay, from 1 to 5. Y times dy. Okay, we do this square root of u, right? Square root of u. Y times dy. Y times dy is 1/8 du. See. Now it's easy. Okay, what this is a power function. Okay, so I directly get it. 1/8 factored out is 1/4. Okay, 1/4 times pi. And this one, the entire derivative we know is 2/3 u raised to the 3 over 2 power. Okay, and then from 1 to 5. Now you know do calculation. So after the calculator, we get, see, the questions ask to find the exact value. Okay, exact value. So we use the exact value. Don't use approximation. And then here is 5 raised to 3 over 2 to the power, and then minus 1. Okay, this is the final exact value, the answer. And this one, we have the last one questions example for you. Can we see? And this is famous, right? What the area or the surface area of a sphere? If we have a ball, what is the surface area? If the radius depends on the radius. If the radius is r and the surface area is 4 times 4 pi times r square, right? Means it's 4 times the area of the middle cut, the middle circle. We're going to prove it. And we look at this, how to prove. So first we need to link this surface area of a sphere to revolution. How to revolve or rotate in the curve, and it's easy. Okay, if we have a semicircle, rotated the semicircle, we get a ball or a sphere. Let me show the graph here. Get. You see this. If this is y, this x, I give you. This is a semicircle. Okay, let me see. Okay, suppose we have this semicircle. Now you know we have to put r here, negative r here, r here. This is a semicircle, right? Semicircle. We need to use this word, rotated. If I simply say this is a rotate. This semicircle rotating about x. What do we get? We do get a ball, right, or sphere. Okay, now. And the original area of a sphere is the area of the revolution, right? That exactly belongs to our topic. What is the semicircle first? What is semicircle? I have to put it there, semicircle. What the function? Okay, we need to rot. You know how to rot. This is r square minus x square, right? This square both sides. You get x square plus y square equals r square. This is the semicircle. What is x? X belongs to -1, or you say x belongs to negative r to r. Okay, now we need to do rotate, and this rotate, rotating about the x. Okay, if you set up in this, now it's almost right. All we need to do is do calculation, but we need the formula. What is s now? So if I put s here, s equals belongs to which type? A basic function rotated by the x, case 1. Okay, if you know this is case 1. If you know this is just case 1, we just discussed. Okay, put the formula is 2 pi y ds. Okay, that the formula. The formula. Okay, how about the ds? ds is integrating along x, right? We will cut x. Okay, integrating along x-axis. Okay, and what is y we have? What is ds? I will going to show you. So now it's the formula. So what the formula? So let me put the formula is integration along x from negative r to r, negative r to r. 2 pi was y there. Okay, I copied. R square minus x square. What ds? Okay, you remember ds? ds is this. ds is 1 plus, okay, because we need the dx outside, so it's dy over dx parentheses. Okay, we see this is the complete integration. Okay, all we need to do is what is dy dx. So let me show you one more step. Get it. Dy dx is what? Dy dx is there. Okay, this is a composite function, right? Do integration is the chain rule. So square root of u is, do you remember? Square root of u is 1 out of 2 times square root of root u. Okay, u is the inner, which means 2r square minus x square. Okay, this is the out times the inner. The inner function u is here. Take a divided to x is negative 2x, right? Okay, you know these two we can cancel. So now this is dx dy. Okay, I plug dx dy in. I plug in here. See what do we have? Negative r to r 2 pi r square minus x square times. Now look, it's complicated, right? But don't worry. Okay, 1 plus. So this time is this square. I have to do big parenthesis. This is negative x, right? Square root r square minus x square, big parenthesis, square. Okay, so this is what? This is exactly dy dx. Okay, put everything here. And now is dx. Look, it's complicated, but don't worry. Okay, you're going to verify, and all these terms not include the 2 pi. This term simplify. It goes to very simple. You know what is that? It's just r. Okay, the answer is r. If I put r to there, what do we get? We will get this negative r 2 pi. That's r. Okay, that's r, and then dx. Okay, I mean all this one just go to r. Just go to r. Okay, and then now you know this is a constant, right? Okay, or you use this is 2 pi r is does not link to x, which means a constant. Okay, and this is power. What is the antiderivative? Antiderivative is 2 pi r. This is a coefficient a times x, right? This take a derivative goes to 2 pi r. Now easy. Negative r to r. Okay, you put it in, this get 4 pi r square. See, is this what we need? Definitely. Have we got the formula? Yes, we do. And that's all. Thank you.